Hello, my name is Ryan DeBrawl, and today I will be performing a code review on several of the projects that I've worked on in the past while attending SNHU. I will be going through them in chronological order. So, first, we are going to examine the final project from data structures and algorithms. Then we'll be looking at computer graphics and visualizations. And then finally, client server development, which I took just last semester. So to begin with, I'm going to open up the solution for my final project in data structures and algorithms. This has been quite a while since I've taken a look at this code, so I'm coming in fresh. So as a code reviewer, I have no assumptions about the quality of this code. So right off the bat, I can tell it's some of my older code because I was very uh, I like to separate things into very clearly definable sections using these ASCII art sort of sets. I don't do that anymore. Um, I've noticed that too many comments render comments useless. For example, why would you need to label a list of variables as variables and constants as constants? They're clearly what they do. Good code should actually explain itself in most cases, unless there's some sort of esoteric reason for a piece of code. Good code should be pretty much self-explanatory. So in this case, this is a project that uses a CSV file, comma separated values file, and attempts to load it into a structure, which is probably could be better enhanced into object-oriented programming using a class rather than a structure. But I think the idea was just to produce multiple ways of interacting with this data. And when I see I used an enum here uh, called mode, so linked list, hash tables, and binary tree searches to iterate across this table or this data that was loaded into memory at runtime. So I can just start going through it, and I think the important part about code review is willingness to accept that there are mistakes. I won't be making any edits today, but I will be simply identifying areas that I think could be better. So again, I've already covered the fact that my commenting style is a little bit verbose. The naming conventions are good, using capital letters for constants, using lowercase and then uppercase style for variable names. The code structure is good, but basically I'm just gonna run down this and see if anything really stands out. So as I'm going through this, I'm looking for naming conventions. I'm looking to make sure there are null checks in place. For instance, right here I can see that there's plenty of room for improvement. I never check to see if the string object is null or white space. So the dot erase method would throw a null exception if this string didn't have any values. So right there, and same thing with the character ch parameter. Uh, without a value, there wouldn't be anything to erase. So there's already room for increased validation on this level within this one function. Same thing here, no null check on the string, but it's always nice to be able to have a method. Oh, and you can see I even created a is null or white space. That's what I commonly use in my daily life for operating with strings, so I wanted to create a shorthand. Now, some people will make an argument that stack jumping isn't a good thing. I could slow down the execution of the application. Stack jumping being when you exit one method, enter another method, and then return to the previous method. I I don't think it's as serious as some developers will lead you to believe. I think it's important to be able to organize your code in a clearly readable manner. Otherwise, it just becomes so complicated. Seeing this would mean nothing at a glance. You'd have to read this code, and this code could occur hundreds, if not thousands of times in a single application. So having a single reusable method, much better, in my opinion. But that's the argument that people will have, is that this would take, using this format over and over and over would take less processing power, less time to execute. I don't even know if that's true. And if it is true, I don't even know if it's even measurable in less than a million uses of this code. So I think this is an excellent method, and I stand by it, other than the fact that we need a null check on the string str parameter. So same thing with the print elapsed time. It's good to have the fully documented comments. Sometimes they can be a little bit distracting. Again, good code should document itself, but it's just become my practice to always write these pretty generic descriptions of what they do, and obviously always include the parameters in the description, so that IntelliSense can pick up off them. You can see the IntelliSense, the string being tested for null or white space. That could be really useful months and months down the line when you're not 100% sure what what a method does. It's nice to be able to have a quick peek under the hood without having to dive down into the code. So let's see, the ticks, again, there's always going to be, I think, missing null checks seems to be uh, the rule here, or the unfortunate reality here. So I'll definitely be adding those. Again, the bid, or checking attributes of the bid, and the bid is a structure. I will make it an object, but the fact that we haven't even checked if the bid is null or not before acting upon its attributes, that's a recipe for disaster right there. Right here you can see the use of that is null or white space function. Obviously, you can see using it twice in this one method, it makes it a lot more readable. So I'm glad it's there. And I did notice that, and some developers like them, the region tags, in this case in C# it's pragma region tags. Um, I like being able to collapse things once I know that they're solid, meaning I don't expect to go in and edit this very often. I expect it to, quote, just work. So once I have a good piece of code laid out, and this is usually just for modeling and reusable private methods, I sometimes put them in regions like global definitions or private methods or something to that effect, just because then when you're interacting with the IDE, you don't have to scroll through a bunch of code that you know pretty much works. I wouldn't do that with business logic very often unless it were in, say, a switch case list. Then you can, in each case of a switch case, you can have these large chunks of code that don't have anything to do with the code that's above or below them. So I sometimes collapse those in region tags too. So it looks like I started using classes. I think the original object was in a structure, and I started using classes just because I wanted to get into object-oriented programming as quickly as possible. So I think I may have actually converted this to a class just so I could work with what I'm most comfortable with, constructors and private and public methods and variables. So everything looks clean there. And so it looks like we start going, this is where it starts entering the actual logic. So we have the load bids method. Again, doesn't check the CSV path, which means it would throw a file IO error probably right here when we tried to parse the CSV file into looks like a parser object. So good to have the try catch at the end. So that's always a smart programming technique right there, as long as you don't use it too excessively. Hit your standard for loop, and we're using looks to be like a two-dimensional array for file. I guess that's the design of this particular object, I'd prefer to use something like a dictionary. Again, that probably would have an impact on um, performance, but at what level does it actually become perceptible to humans? So here's another method. I'm just going to F12 into it, and uh, sure enough, it's about what I expected. It's a clean method, but it doesn't have and I actually already covered this one, but just as a ongoing effort to identify limitations in the code. So to me, this looks pretty clean. Again, it's just most of this is pretty well written. I'm actually surprised how well organized this project is. It is the final project for this course, so it's obviously submitted for a large chunk of my grade, so I took a lot of time to clean up the code, I'm sure. I don't quite recall writing any of this code, but I can see, like I mentioned earlier, I can see that it is my code. So again, going through null checks, uh, find a little, do you ever see null pointer previous node? So that I'm not actually familiar with what it's saying there. I would then probably just go in and Google that, and Stack Overflow would probably have an immediate answer to it. It's probably some minor formatting issue. Probably, let's see, dereferencing null pointer previous node. Previous node dereferencing. Yeah, I'm not familiar enough with C++ off the top of my head to be able to identify this, but right there, usually the answer is right there. So if I go to the warnings and dereferencing, if I copy that and go off to Google, I'd probably be able to find an answer pretty quickly to how I can get rid of this. Worst case scenario, I could always ignore the warning using the warning code, but obviously I want to code as per the rule set that my IDE is operating under. So going through the rest of the, continuing on, while loops, I'm never a big fan of while loops because obviously there's no guarantee that it'll ever end if something should go wrong, but it's probably the way the original project was designed. It seems to be, let's see, the while is just the head. Okay, so it iterates across, starting at the head, goes through all the bids, and returns. So, oh, this is the search, this is the binary search tree. So this is where it splits off into different paths as it goes through the bid collection. So here's a little method to. So this right here, there's a good example of when methods aren't useful. That's 3 lines of code to return what is essentially already available. So it used to return the current size. So this I could see somebody arguing to get rid of it. I wonder if it's even used. So it is. Hmm. I'll have to look more closely at that, but it seems like something that could not exist. Yeah, it seems like it's programmatically getting the size of a linked list, which you can just do manually. You don't need to have a separate helper function to do that. And I can see I collapsed all this inside a region also, which as I go through this as a code reviewer, I'm discovering the limitations of, because now it does help organize it, but it's also making these assumptions that everything inside this is correct. So everything I just reviewed seemed to be part of just the linked list implementation. As I recall, this application allowed you to search across that loaded CSV file in 3 different methods, depending on what you chose, and performs similar tasks. It just runs it through these different modes to demonstrate the various types of iterating across the collection. So this UI part is probably where I'd find the main method, and yeah, most of this you can see it's very switch cases, so it's just routing code based on input, and it's just how the console is printing data out. So most of this, since it doesn't have any parameters, they're probably pretty safe. I'm probably working with a lot of things that are globally defined. So I don't really see anything wrong here. The divider here, I remember seeing that up top. Okay, so it's used very often. So reusable code is always an important thing. Having this code, which is just a bunch of dashes, I believe, but not having to, uh, yeah, having that available at any time as a constant string is useful. So I can jump back down to 800 and continue on. So yeah, this just looks like basic code for writing out uh, the console commands. And it looks like I have a little clock in here to measure the time it takes to traverse the collection. So here's the actual render menu. I can see that it's got the UI right there where you select and you operate on the collection, and then based on your selection it performs different actions. And at the very bottom here, very succinctly, it actually parses the arguments, which I'm actually interested what arguments it's taking in. Looks like you can start the uh, application with different command lines. I don't even remember that, but that's pretty interesting that it allows you to specify a path. So that's neat that rather than having just one path, I could actually specify a path to the CSV file, and it also allows you a default bit ID, which I believe is probably the first record or the primary record that I'm dealing with when operating on this. So overall, the code looks pretty good. A little bit too much when it comes to ASCII art in the comments, and I could clean up some of the functions. Definitely have to add null exceptions to it. So I wonder if it works. It's been quite a while since I've started this up, so let's take a look here. Looks like it's working. You can see that divider constant. This application is designed to simplify locating records. How do you want to use it? I'll try the binary search tree. It says it loaded up the application in 0.4 seconds, and then it tells me the mode. That's nice that it tells me what mode it's in. Can I go back to, yes, I can go back. Hello and welcome back. I will now be reviewing my final project for computer graphics and visualization. This one Took me quite a while to complete. I'm a game player, video gamer. I've always been interested in software development, in specifically in the realm of game development. So I've played with the Unity engine and Unreal Engine, and very early on DirectX in DirectX 9C. So when I started this OpenGL course, I was very excited to learn. It was challenging. This is also a C++ project utilizing various libraries. All of them had very inscrutable names: Glad, Glyph, Glam. Uh, I remember this one being very challenging because at the sixth or seventh week of the course, I needed to start over completely. The well, I'll tell the story as I go through it. So we have an application here. Just so we have rather than wait till the end to demonstrate, I'm going to show it up front just so that we can understand what we're looking at while I'm going through the code. So my intent was to create a recreation of a scene from the point and click adventure Myst. So this is the part where the library is in the foreground and there was supposed to be a little sunken ship here. Didn't have time to get that working, but as you can see, I did take the time to create a day and night cycle, so I was very proud of that. Um, right now I have it in kind of ghost mode here where I can float through things, and I don't recall the character or the hotkey now, but one of these keys, I have different functions here, but one of these keys actually locks me to the ground so that I have some basic collision detection, but it's only measured by your distance, like left and right. There's no actual collision detection with the objects. So my goal here would be to enhance it a little bit so that it can, at the very least, allow me to walk up these stairs. So it would identify where my quote actor or my player is and determine what the elevation off the ground should be, so it can simulate the effect of actually uh, having collision detection walking around the environment here. So you can see here that little flickering glow. I especially like that, working with the little algorithms uh, to create that flickering effect. It's all just using random numbers and bit flipping or flag switching. So is it glowing up or is it glowing down? So now that you have a general idea of what the application is, I can show you the moon setting, and I think the sun rising any second now. You can see the sun coming up there. So I was very proud of this, but it did take quite a while to get it right. So I'm gonna start going through the code and see what we got. So first thing I did was, it was very difficult to keep all the dependencies together. I ended up unfortunately including a massive amount of external dependencies. The correct way to do this would be obviously to leverage the libraries uh, themselves, and it just took much too long. I ended up just throwing entire chunks of code into the bin, into the actual build location just to get it to work. So definitely cleaning up the structure of the application. The actual file folder would be high on my list of enhancements. So the code itself, you can see here, toggle first person mode and toggle no clip mode. So I'm just going to jump into those real quickly. So here I believe is, yes, here you can see it gives the illusion that I have collision detection, but in fact it's just a measurement of a kind of generic space. So I just roped off an area and said, oh, you can't go beyond these x and y coordinates, or x and z coordinates in this case. So that's kind of a quick way of getting through it. And then F3, this is an isometric camera view, or orthographic camera view. It's just a different way of kind of configuring the camera and the lens. So you can see if it worked properly, it would kind of give you a bird's eye view of the application. I'm not real too concerned about continuing on with this. My intention was to create this kind of first person perspective, and I think I succeeded fairly well in that regard. So enough showing off the actual result. Here's the actual code. So much cleaner implementation of comments than my previous example. I see I'm still using a lot of regions to divide things up. Here's an example right here of a lot of redundant code. So this GLAD library should just be referencing off a DLL, a dynamic linking library. But for some reason, I couldn't get the dependencies to work exactly right. So I ended up taking all that code and sticking it in my application directly. I regret having to do that, but there was a time constraint. So this entire library is sitting there right out in the open from lines 48 to 2000. So that would be a huge improvement, would be to simply actually get the dependencies to work properly so I can um, use the GLAD library as a compiled dependency rather than actually injecting the code directly into the application. So this was my main issue, was the shaders. So when you actually look at the shader file is just basically a bunch of inscrutable math language. But it's what identifies what gets painted on screen, how objects and their lighting interact with each other. It's very complex, and so writing a shader, at least at my level, was out of the question. But utilizing another person's shader, I could. Unfortunately, the one I used only allowed for a single light source, and as you saw in the example, there are multiple light sources. There's the sun, there's the moon, there's the flickering candle. I believe even this little fountain right here in the middle, it has its own light source. You can see it if you zoom out. It's emitting light for no particular reason other than I thought it looked nice. But having the idea of the shader is that it can allow uh, it defines how things are drawn, like how one light will interact with another light. So if I put another light source overlapping this light source, what you see as the textures, they would interact differently. So if I put a blue here and a red here, you'd get a purple light somewhere cast on the stone in between. So I had built my entire application using the default shader that came with the early examples, and that ended up forcing me to basically rush this final project. So that's why you have large chunks of redundant code or code that shouldn't be there. I spent a lot of time going down the wrong path. So right here I'm noticing some weird formatting issues. If I do Control KD, it seems to be all right, but generally that would be the way to uh, format the else conditions. So the code is very large and complex, so I won't be quite as picky about what I'm seeing here, but generally, and I'm just going to go through it and show you how it works from behind the scenes, but the same rules apply. Null checks on every level and clear, clear, meaningful comments. So here's the shader class. Again, utilizing the object-oriented programming, and you can see it loads a bunch of stuff up. All very complex math and geometry related uh, things that are encapsulated into this one shader object. You have the camera, you see using enums to determine which directions, using constants to determine various static and unchanging values like how quickly you can run and how high you can raise and lower your head. And then I believe these world bounds is how I define those boundaries in the faux collision detection that I demonstrated. So this camera is also a big copy and paste job. So I didn't really write this camera. I simply edited it. So if you look at, if you go through this, you can see that I just tweaked things as I wanted them to be. Basically, I tweaked them to work as closely as I could to the first-person shooters that I'm used to playing. So you can pitch about 90 degrees and you can move at the speed that felt comfortable. But all of this is, again, a copy and paste from another class file. So this camera class, in fact, all these classes should probably be defined in their own files. But I just had such trouble getting these references to work, and I'm not really sure what it was at the time. I'll have to figure it out, but basically the code's good, but it shouldn't all be crammed in here. I mean, the fact that I'm only a quarter done, I'm already on line 3000, is not a good sign for the organization of the code. So moving along, you can see I have some structs instead of objects. Those are fine. There's no reason you can't mix and match them, but I'm guessing that these were the original objects that we were working with. And here is uh, the blueprints for basically everything you see in the world. This was incredibly time consuming, as you can see here. I had to basically map through trial and error the 3D coordinates and 3D rotation of every single object you see in the world every single time. I was hoping in the course of the class that we would learn how to load in models or meshes, and there was some basic instructions on that in the second to last week, but by then I had too far committed into the project design to do anything other than simple cubes. So you can see it was a tremendous amount of work of just trying to make sure everything lined up correctly, and I did the same thing with all the light sources too. So the moon's got uh, a blueprint, the fountain. These are all the light sources and the mappings for different various lighting attributes. And then there's my day-night cycle, and this is where I was mentioning earlier with the candle flicker. I did this multiple times where I enjoyed writing the sort of, I guess algorithm is the correct word, but they're very simple logic, just nested together. So if it's going from day to night, you want to decrease the lighting for all three color channels. If it's going from night to day, you want to increase it. And if it reaches a certain threshold, you want to switch state. And the switch state just basically flips it from one to another and starts the process over again. And then the candle's doing sort of the same thing. And then you can see I made some helper methods and I used some random uh, seed math to kind of create that random flickering effect. So it picks an arbitrary point in a range. Looks like between zero point 0.1 and zero point 0.3, which is 30%. So 10 to 30% full light, and then just picks a certain point and then moves towards that certain point. So I think it was highly effective. Uh, so you can see, and it works better at night, but you can see it sort of gives a somewhat realistic flickering candlelight, and really what all it's doing is choosing an arbitrary point and then shifting the light in increments. I can see right here a to-do, use delta time for smooth transitions. So right now this is doing it as quickly as the math can execute, and that's not what we want. What we always want to do is multiply it by the difference between each frame. I think for some reason I didn't have time to implement this. I don't recall, but that's what gives you the smoothness, because it would be uh, these increments would then be locked into the same speed, the rendering speed. So rather than making large leaps and smaller leaps because of the change in the frame rate, I could actually lock it into how the application is functioning. So the delta time, the distance, the measurement of time between the rendering of one frame to the next. You always want to multiply that coefficient in anything that updates the physics in a 3D simulation. So you can see I did that for the moon cycle, the moon day and night cycle, the candles, and then this is where the actual application starts to come in. So you got your function prototypes, which I guess is just the way C Sharp works, or the way, sorry, C++ works, where they want you to find the functions before you actually use them. I come from a C Sharp background, so I don't really understand why it is that way. I should read about it more, but basically I tried to organize it so that they're all in logical order and that I can reference back to them quickly. So in this case, it's you can set up the resolution. So I was proud of this, that I was able to figure out how to actually automatically make it full screen, or actually fake full screen. So it's actually a windowed application without any borders on it. So I can actually measure the user's resolution and then make it full screen for them. That way I didn't have to do a fixed uh, um, resolution, so that it occurred in this little window as a more immersive quality to it. And then I got my global key presses for changing the no clipping mode on, and these all appear in the console behind the actual OpenGL window. So you can see the initialization of the application, and this is where the application actually begins. So it sets up all the OpenGL things, sets up the resolution, and then returns true. Let's find where that gets used. Okay, so it gets used right here in the main window, located at the bottom, which is just a preference I like to use, is after everything's been set up, finally you introduce it. So again, it's very succinct. It initializes the application, sets up those shaders, which allow for multiple light sources, loads in all the textures. You can see we're taking JPEG files and loading them into memory, so that I can quickly apply them to the different primitives that I created. And then here's all the meshes. The actual mesh may not be the correct, it's not really a mesh, it's actually just a bunch of primitives that I hand coded. Again, it was a extremely laborious process of getting all of these coordinates to work. So this is what a cube looks like in coordinates. So positions, the normals, which is a right angle to the position. So basically that gives you a way for light to bounce off of it. And then the texture coordinates is just the way it wallpapers a side of the cube. So from 0 to 1 would, or from one, as an example, from 0 to 1 would be from the far left to the far right, or from the upper left to the lower right. So it's all very arbitrary and confusing looking now, but at the time I understood it very well, so I'll probably have to go back and review this. This would probably be a good place to use constants rather than to have all these numbers, but of course that's a lot of refactoring, uh, or 10 seconds if you do the find all and replace correctly. So I might use constants for this, just to clean it up, so it's more flexible in the future. But going back to where I was, in the main, loads up the meshes, loads up that pyramid in the background, loads up the lights, uh, prepares the shader for use, and then you have the main rendering loop. And anyone Hello, welcome back. This is my code review for the client and server development class, my final project. This one is a Python application, which is a CRUD application for manipulating data in a MongoDB database. Unfortunately, I don't have a working copy of this because this class took place on a VM hosting Linux and I've since lost access to it. So I have all the source code, but I can't actually make it run. So thankfully I took some screenshots of it that I can show you, and that way you can get an idea of what I'll be demonstrating. Ultimately, my goal would be to get this application up and running on my local machine here rather than having to depend on a Linux virtual machine. So if you take a look at the screenshots here, it's a very simple HTML page with a table and some pagination. It also takes the table data and plugs it into a leaflet mapping instance so you can see where the animals were found. And then it also uses a pie chart library to actually calculate what became of these animals, whether they were adopted or returned to the owner or unfortunately put to sleep. So I'm gonna just go through the code, but it's a fairly straightforward application, CRUD application. Again, it's using a MongoDB database, and it's written in Python. So it's composed of two main sections, the CRUD object and then the actual UI. So I'll just quickly go through the CRUD object, create, update, delete. So we have this animal shelter object, and we have our constructor, which sets up the connection to the actual application using the username and password and specific port. And then you have your basic database operations. And so create, read, update, and delete. As you can see here, I'm using more null checks immediately. I always like to code fail first philosophy, the fail first philosophy where check the data before you try to operate on the data. So that's very important, and it leads to a lot less headaches. So on every single level, expect it to fail. So once you've inserted, check if it has been inserted. Don't assume that it worked. Don't assume anything worked, especially when you're working with data that comes from a third-party source, be it from a database or from that CSV file earlier. Assume that the data is bad at every single level. So you can see it's a very clean implementation of some database operations, and that's implemented here in the actual UI. This is using a plugin called Dash UI for the Jupyter Notebook IDE, which again, I don't have access to now. I'm hoping to be able to port this into something that will run on Windows, so I'd need a copy of the database or a big SQL file that allows me to restore a MongoDB. I guess it wouldn't be a SQL file. Whatever way they back up a MongoDB, I need to be able to set up a local instance of that database, and then I'd be able to get this application up and running. So you can see here the object in the CRUD file is being imported into this file. This is exactly what I needed more of in my previous example. The OpenGL is organizing these functionalities into sensible areas, so they're easier to work with rather than having this big monolith application where everything just can get lost. So in this application, it generates a HTML document using this Dash library. So I'm very familiar with UI design. I do it in my everyday life, so I'm very familiar with traversing the DOM and using CSS. So while it was a little bit different, I was able to visualize divs with an image inside and an H3 tag. So it's basically building a HTML document using a Python library to set up all these controls, and then it uses these callbacks to actually bind the events. So in this case, this is the event binding for each of the radio buttons, and you can see it's utilizing the read function from the animal shelter object to grab uh, uh, data directly from the database. So you can see that's all the levels of the application coming together. You got the database being pulled with using this PyMongo library, which is then being returned to the UI in this data frame object, and then that data frame object is then rendered into HTML and populated onto the UI, and then users would then interact with that table to change it. So I was very happy with how the application turned out. I'm least familiar with Python than most languages. It's obviously some would consider it a beginner's language, but it's as complex as the application you need to make, right? So um, I'm happy with the code quality, but again, I don't have a working copy of this. So my goal here would be to get this database up and running on a Windows machine and then either port it out of this Jupyter Dash UI or see if this Jupyter Notebook is available for Windows. So it's unfortunate that this whole thing was developed on a virtual machine and I don't have a working copy of it, but that will be the challenge, creating something that is uh, um, cross-platform compatible, I guess you could say. So this has kind of been an overview of my database interactivity project. And all in all, thank you for taking the time to sit with me and do this code review. I think I've got a fair amount of work ahead of me, but I am proud of what I've so far got accomplished. A lot of it will just be cleanup and validation of fields and values whenever they're entering. There's no null checks here, so I think it'll be a good experience. I think the revisiting all these different projects has been very lucrative simply because I get to see the evolution of my own uh, prowess at development. I'm a professional developer by day, so it's how I make my living already. But I only usually work with C Sharp and JavaScript and Transact SQL and SQL Server databases. I'm in a very narrow band of programming. So being able to explore different libraries and different languages gives me a wider perspective on how things work together, and it's given me the ability to look at my own code that I write on a daily basis in broader terms, and it's been very helpful revisiting these projects, and I hope that I'm successful at each of these refactorings, make them cleaner, more resilient, less prone to bugs, and just more streamlined. So thank you very much, and goodbye.